and unfortunately I can't bring it up for you to see, so you'll have to listen to me very carefully. So it says, a pigeon was sitting 8 meters from the base of a telephone pole.
Uh-oh. Okay, wait.
All right,
Hang on.
so you got that?
Oh my goodness, I feel like I should be drawing pictures like Nate. Hang on.
Drawing pictures. Are you good at drawing pigeons? Because it's got a pigeon. The
It's
viewers
a little
need a
bird.
pigeon. So he's sitting 8 meters from the base of a telephone pole and flew 10 meters to reach the top of the telephone pole.
Uh-oh, wait. Okay, so he's sitting at the end, and he's 8 meters away.
Mm-hmm.
Okay.
And he flies 10 meters to reach the top.
Oh, so he flies directly to the top.
Yeah.
Oop, oop, oop. I kind of know what kind of problem this is.
How tall is the telephone pole?
Okay, I could do this. So this is normally a Nathan problem, but I can do it just as well. Do you like my picture, Sam?
Oh, that's beautiful. That's
It's my
almost as
pigeon.
good as Nate's.
And it's my telephone
Almost.
pole. Wait, let's make it like a telephone pole. I don't know, like what does telephone poles
Look at
have
that
on
cute
it? It
little
just
pigeon.
has like little things on it, little wires. I don't know.
Perfect.
So this pigeon, he's standing at the bottom, and you're saying, so he's 8 meters directly away from that telephone pole.
Yeah.
And then he flies, so I put little dash line of where he's flying. He's flying directly to the top of that telephone pole, and it takes him 10 meters. And then we wanted to know, how tall is the telephone pole? Well, one thing, I'm going to make an assumption, is that the telephone pole in the ground, if it was constructed correctly, should make a 90-degree angle or a right angle. And what you can kind of see here is that the shape or the path of this pigeon, the telephone pole and the ground are all kind of coming together to make a right triangle. And one of the ways that we can find missing sides for right triangles is with the Pythagorean theorem. And what the Pythagorean theorem states is that if you take your legs of your right triangle squared and add them together, they should equal the length of your hypotenuse squared. Now the hypotenuse, C, is a fancy name for just the longest side of your right triangle. Or another way to think about it is the side opposite of your 90-degree angle. So opposite would be if we took this and kind of followed it across here, that would be my opposite side. So either way, longest side or opposite of 90-degree angle. So what we can do is we can use this formula to plug in our knowns and then solve to find our unknowns. So one of our legs is 8 meters, so we'll say 8 squared plus, and we don't know the other leg, that was the question mark that I put there, so let's call that other leg B. So we'll say B squared is equal to, and as we just talked about the hypotenuse, our hypotenuse in this case is 10, that's the path the bird is taking, and so we would say 10 squared. And then we have an equation with just one variable, so that means we need to isolate that variable, and when we do that, it is solved. So first we would simplify anything that we can. So 8 squared is the same as 8 times 8, so 64, plus b squared is equal to 10 squared, which is 10 times 10, 100. And then we want to think about getting rid of everything that's on the same side of the equation as b. So we'll subtract 64 from both sides. And it's gone on the left side. And on the right side, we end up getting 36. And then to undo a square or get this b by itself, we're going to do a square root. And b is going to equal 6, so positive 6 and also negative 6. And then Nathan always explains this, and I think it's wonderful because a lot of geometry teachers leave this out. When we square root, we really do have both a positive answer and a negative answer. However, when we are solving for a distance of some kind, a negative answer makes no sense. I would never say that I was sitting negative 4 feet away from Sam. That just does not make sense. We don't measure distance with negative numbers. We always think of the absolute value or the positive version of whatever that is. So even though a square root always gives us a negative answer, we will write that down. That is a solution that we will throw out because it makes no sense. So then what we can say is that B is 6, or we could also maybe say then in distance that that telephone pole is 6 meters tall. He should have just climbed up the telephone pole instead of flown there.
Opposable thumbs.
Yeah.
Shorter distance.
He
Yeah.
should have just climbed. I don't know. But yeah, so Pythagorean theorem, it's a really good way to solve these kinds of problems. You'll see a lot of shadow problems, objects that create shadows, what's the direct distance between the top of that object to the ground. But Pythagorean theorem.
Subscribe!
Come on, push the button.
You know
Yeah, you want
to.
to.
Do it.